This is solving an equation involving logarithms on both sides, problem type 1. I think we also have a problem type 2, so there'll be a video for that. So these equations have logarithms. You have at least a couple of logarithms floating around with the same base, but there's also like a number that's not inside a log. And so it's the strategy we use is a little different if you have kind of everything trapped inside a log versus if you have a number like that. So let me write this guy on my little whiteboard here. So we have negative log base 5 of x plus 1 equal to 1 minus log base 5 of x minus 7. So the first thing we're going to do, and honestly there's different ways that you can go about solving this as usual with algebra, but the first thing we're going to do is kind of solve for this 1, the number that's outside of the logarithms. So if you have some kind of expression outside of the logarithm and it's just going to be a number for us, kind of get that by itself. So let's get the logs together, because what we're going to try and do is get this written as log base 5 of some stuff equal to that number 1, so that we can then sort of rearrange and write this as an exponential to solve. Okay, so that's what we're shooting for. So let's get both logs on the same side. So I'm going to add log base 5 to both sides. And in order to kind of like see how to do, well, I'll just go ahead and write it. Okay, so here's the way, actually I would not write it. So negative log base 5 of x plus 1, so that's what we got right there, plus log base 5 of x minus 7 equals 1. So this, I actually would want to sort of think ahead and think, okay, you know what, if I switch the order of these and wrote this as the log base 5 of x minus 7 first, right, and that's positive, and then minus log base 5 of x plus 1, it's a little easier to me to see that, oh, we want to use the quotient property. So we're now going to combine this into a single log using the quotient property, because that's a minus. There's, again, other ways that you could do this. I think this is the easiest way to go, though. So we're now going to have log base 5 of x minus 7 over x plus 1, right? That's what the quotient property says. We can take this thing over this thing and put it into a single log base 5, and then equals 1. So now we're at the point where we can rearrange all this mess and get to something that is a little more familiar for us to solve. And so we're going to use the definition of a logarithm. The base of the log becomes the base of the exponent, and the log is equal to the exponent, right? Or you can think that BAP, base answer power. So 5 to the 1 is equal to the stuff inside the log. I guess A could also stand for like argument, right? What goes into the log. Anyway, sorry. Okay, so 5 to the 1 is equal to x minus 7 over x plus 1. And it doesn't matter which side of the equals you put these on. So now 5 is equal to x minus 7 over x plus 1. So we have a, I'll just go and write that. We have now one of our favorite rational equations. Those are themselves not the easiest things to deal with. But this one's not too bad. We just need to multiply both sides by the x plus 1. So when we do that, just don't forget that you're going to want to distribute that 5. So 5x plus 5 is equal to x plus 1's cancel. That's the whole point, is we get rid of that denominator. So x minus 7. So now, oh, this is not bad. So subtract x from both sides, we have 4x. And then subtract 5 from both sides, we get negative 12. And this even works out to a nice whole number. X equals negative 3. Which maybe that's the answer. But remember, one fun thing about logs is that no, that's not what I wanted to do. They have to be checked, right? You can get those extraneous solutions. So as long as you check in a version of the equation that's like before you used any properties, and definitely before you dropped off the logs, then it should be okay. I think it's probably best to, though, just check in the original version, whatever you had to start with before you did anything with it. So, do that over here. So check, and at least we only have one answer to check. So negative log base 5 of negative 3 plus 1. Okay, I would just stop here. Look, this is going to be log of a negative 2. That we can't do that. You cannot take the log of a negative number. You can, it's possible that this negative answer would work if this was like negative 3, if the problem had been like plus 4. That's fine because that would work out to being a positive value that you're putting into your log, but that's not what we have. This is going to end up being log of negative 2. We can't do that. And then on the other side, we'll have another log of a negative number as well. So this is done. This does not check. That was our only possible answer, so that means this has no solution. So all that work for nothing. Well, we did find out, I guess, that this particular equation is nonsense. Let's see if I did that right. Okay, that looks pretty good. Let me just see if there's maybe one that looks a little different. This would be very similar, but this one would be where you would end up doing a product property one. Here, I'll set it up. If you're like, I'm good with this, you can just stop the video and go do your thing. Okay, so log base 4 of x minus 5 equals 1 minus log base 4 of x minus 2. So for this one, we would add this log base 4 to both sides. We happen to have that 1 again. It's not always a 1. But we would get log base 4. It doesn't matter the order because they're both going to be negative minus 5. They're both going to end up being positive logs. So that means we're going to use the product property. So this plus sign tells us, okay, we're going to multiply the stuff inside the log. So we'll have log base 4 of x minus 5 times x minus 2. So you can just write it like this and then kind of deal with multiplying that all out later, but you are going to want to multiply that stuff out. So I'm going to go ahead and rewrite this so that we don't have to have a log in there. So 4 to the first power equals the stuff inside. And now I'm going to actually just multiply it out now. So x squared, and then minus 5x minus 2x would be minus 7x, and then plus 10. So we're going to have this 4 here. So notice we have a quadratic, right? So you're either going to get a quadratic or a rational equation, probably. So we need to get that 4 over with the 10, so we have 0 on one side, and we can solve by factoring. So subtracting 4 from both sides would give us 0 equals x squared minus 7x. 10 minus 4 is 6. And this should end up being, for the ones that we get in Alex, it should end up being something that's pretty easy to factor. So it looks like x minus 6, x minus 1 is what we would get for that. So we're going to get, our possible answers are x equals 6 and x equals 1. Okay, so let me erase this. Whoa, okay. Oh, okay, I got it. So let's check it. And remember, we want to check in the original. I said I was just going to set this up. Do y'all hear my Roomba got stuck somewhere? Okay, so let's do x equals 6. Log base 4 of 6 minus 5. Okay, that's a positive value. I'm going to keep going. Equals 1 minus log base 4. Sorry, this is so messy. 6 minus 2. And so that's a positive value. So I kind of am feeling like this might work out, but not necessarily. We got to keep working on this. So log base 4 of 1 equals 1 minus log base 4 of 4. Log of 1, or log of 1. Yeah, log of 1 is, all, no matter what the base, is always 0. And then we have 1 minus, okay, the bases match, so that's 1, so this works. 0 equals 0. So we at least have that x equals 6. Let's see if x equals 1 is going to work. You might kind of be looking at the equation going, nope, that's not going to work. 1 minus 5. That's immediately we have a negative 4. That you can't take the log of a negative number, right? So that guy's done. So it is indeed just x equals 6. Okay, so there we go.